Today in class, we looked at graphing equations in slope-intercept form. So we're still using slope-intercept form, y equals mx plus b. M is still our slope, b is still our y-intercept. The steps that we're going to walk through, we're going to plot our y-intercept. We're going to use our slope to find other points to plot. And then when we're finished, we're going to draw the line because there could be points in between, and put arrows on to show that it's going forever in both directions, and then we'll label it. So here's what that looks like. The first example here is y equals negative 2/3 x minus 4. So if we look at that, that is y equals mx plus b, right? If we're comparing. And so step 1 says to plot the y-intercept, which is, remember, where it intersects or crosses the y-axis. So if we compare our equation and slope-intercept form, we can see that our b in this case is negative 4. So our y-intercept, our b, is negative 4. Remember, we could write that as an ordered pair, 0, negative 4. And step 1 says for us to plot that on the graph. So on the y-axis, we're going to go down to negative 4 and plot our point. That is the point, 0, negative 4. Okay. Step 2 says to use the slope. Sorry, this got cut off. Use the slope to graph other points. And so, well, we need to figure out what our slope is. And if we compare the equation, remember, slope is the coefficient of x if it's written in slope-intercept form. And so in this case, our m is negative 2/3. But it's helpful. We know that that means as x increases by 1, y is going to decrease by 2/3, but often it helps us to break that down into rise over run. So I could write that. My rise would be negative 2, and my run would be 3. So then we need to keep in mind what direction that tells us to move and how many units. So if my rise is negative, that tells us that we're going to be going down. So this means to go down 2. And my run is positive. That tells us that we're going to move to the right. So we're going to go to the right 3. Okay, so if we go back to our y-intercept, we're going to, from that point, we know that point's on the line, so we're going to start there, and then we're going to do exactly what our slope told us to do. It said to go down 2, 1, 2, and right 3, 1, 2, 3, and this is where my new point should be. And then I could repeat that again, down 2, right 3, and I've got another point. When we're graphing lines, we often, especially as we get into our next unit with systems of equations, we want to extend that graph, and we want it to be as accurate and precise as possible. So when we're graphing lines, we are going to what I call reverse the slope. So we're going to reverse it and find some other points. So instead of going down 2, we can go up 2. But if I go up 2, then I'm going to have to move left 3. Actually, mathematically, that matches up with the slope, right? We found our slope is negative 2/3. That is equivalent to 2 over negative 3, right? So a positive 2 would tell us to go up 2, and negative 3 would tell us to go to the left 3 for that. So that is equivalent to that negative 2/3 that we found from the equation, okay? So that mathematically is okay. So we're going to go, and you could actually check that too, starting at this point, the last point that we did. If we go up 2 and left 3, it actually puts us back here, so we know that we're on the right track with how we reverse it. Up 2, right 3, and then if we keep going, up 2, right 3, there's our next point. Up 2, right 3 again. There's our next point. I can do it one more time. Up 2, right 3, and there's our last point using our slope. Then step 3, draw the line. So we're going to put the line. We're going to put arrows at the end to indicate that that continues. And then the last step says to label it. Often when we see lines that are graphed, they're labeled with the equation written at either end. So that is the line that represents y equals negative 2/3 x minus 4.